Hey everybody, I'm gonna spend the next hopefully 40 minutes telling you how to make sure we all lose jobs within a few years. So this is going to be about writing code that changes your code for you. This is not a new concept, but it's coming up more and more. It's coming up with more uses, and it's time for everyone to start using it to simplify their lives. Because seriously, refactoring is only fun if you have like 1 or 2 files to refactor, not if you have 800, right? So that's what we're gonna do today. This is a result of some experiments I did. So it's something I just learned, and smart people told me that someone who just learned something is going to be a better choice to teach you that than someone who knows it for like 10 years because they know what you're struggling with. And this is what this talk is going to be about. I'm going to show you a few bits on how to get started with writing your code shifts or whatever that's called, how to write code that's going to do your refactoring, and what are the first problems that I encountered, and I can help you skip that. Okay, let's get started with a case study. So I'm working at a company where a neighboring team is maintaining a web UI in JavaScript and all that stuff. It's a 10-year-old company, so it has seen its rewrites. The current code base is also a few years old already. There's a lot of refactoring to do. Obviously, some React on the front end, some older stuff running around as well, some backbone here and there. So there's stuff to rewrite, definitely. But we don't want to rewrite the whole project ever again. That happened 5 years ago and took about a year more than expected. So that's not an option. So instead, you know, you can always get computer to refactor your code, right? And this is a bit of a screenshot. I hope this doesn't apply under NDA. So I'm not disclosing anything important by telling you that a guy on a neighboring team did run a bit of script that refactored their code base, and it made over 300 changes, and he made it all at once, hence single commit, and I gave him a medal emoji. Full disclosure, right? Okay, that was me. Anyway, the change was fairly simple. So they were changing how they do translation and internationalization, and they needed to clean it up a little. They didn't want to ship the translation thing on this context for a React component. And as you can see, the code is seasoned because it says react.createClass. This is the next step. He's already refactoring that too, by the way. And maybe if I tried really hard, I could refactor this with a regex without making too much of a mess. But then this .t is kind of hard to catch with a regex without messing other things up. So this was a good thing. This was a good case where using abstract syntax trees and the tooling around them was a good idea. Hence this presentation. So where regular expressions can be used, you can use the thing I'm going to tell you about. No spoilers yet. So the biggest thing that you need to take into account is sometimes when refactoring, you need to make decisions. It's not just replace this bit of text with that bit of text. We're, you know, it's 2019. We're not going to get paid for reading text and replacing it with something else. You have to do a bit more. So I'm going to show you some code modes that already exist. And first, I need to explain what a code mode is. So code mode is the term that was coined to refer to these kind of programs that take your code analyze it just like a compiler would, and then make changes to it and print it back into code. This already sounds complicated, but wait for it. It's going to get worse. So I'm going to show you a quick example to make it a bit easier to grasp what this whole thing is about. So here's a bit of code that I'm showing you against a NDA that I've signed. And this is a bit of old React Create class stuff with some render function and some function on this that calls something when you click. Nothing special, like, you know, the kind of regular React component that you tend to see a lot. And now we're going to take some code modes that already exist. So React is publishing code modes. If you didn't know, check it out. If you have some refactoring to do, if you're behind the curve on using some of the new syntax, this is going to be helpful. What I should run is this line, but without the force. The force thing is helpful when you want to make a demo, but not for other purposes, really. So I'm gonna run this bit. It's gonna ask me some questions that I don't care to read, and it does its work. So thanks to the editor, you can notice that this line changed from create class to action icon extends component. It moved this function a bit. Well, nothing special, right? Also something we could do with a bit of a find and replace if we were careful. But what I wanted to show you is that this code mode has some ifs inside of it. So if I undo the change, yeah, that's a bit too much. If I undo the change, we're back to what it was. If I happen to be using mixins, which painfully I've sometimes had to, yeah, then the situation changes. So when I run the same exact code mode and ignore the same exact questions, it did something else. So the new syntax for create class is this, and we couldn't use extends with React component because it doesn't support mixins. So here we can still use mixins. It creates a create class for you. It adds a require. You need to require this and you need to install it. So installing it is the manual step, but everything else is done for you. It's even added an extra comma here. Fun. So the big thing is that this is way smarter than regular expressions. Yeah, and I could run the second example. I don't really see the time anywhere. This clock is very helpful. So the second example is very simple. Just let's do it. I'm gonna have less time for failing at demoing more advanced stuff. Okay. So the next step would be like we're using prop types from React. This is the old way. And if I run this, ignore a few questions, we get prop types added here. And you obviously can run it across your whole code base, the code mode thing. React code mode is built on top of some tools I'm going to show you how to use, and there's a lot of work put into running this in parallel and making it efficient to explore your code. So yeah, let's look behind all of this and see what's there. So the first thing I need to explain to you is abstract syntax trees, and I'm not gonna go too deep into that because, well, it's not a computer science lecture. But what you need to know is that abstract syntax tree of your code is something like document object model of your HTML. So you're writing some text and it's supposed to mean something. It generally tends to mean something. And then if a compiler or interpreter or anything that needs to understand the code is using it, it's not using your text, it's using an object model of that. And that's the abstract syntax tree. So what you see here is a bit of code. It says that the demo variable should have this content. And you can see a tree which contains a literal. Literal is one of the object types you get in an abstract syntax tree. And this is the string. And then it has an identifier. That's where the demo word is located. And then there's a variable declarator which binds the two. So the unintuitive thing about abstract syntax trees, at first when you look into it, is that if you have something that works, if you chain a few things, if there's a function inside of a function, you need to go up to get a bigger scope. You need to go down to get to a single element. You're not moving in your code linearly. It's a tree. Very confusing at first. So you probably already use abstract syntax trees a lot. So everything you're used to, Babel, Prettier, ESLint, minification, everything is built on top of abstract syntax trees. The browser also uses that to parse your JavaScript, to feed it to some horribly complicated machine and turn it to machine code that runs. Your JavaScript doesn't run anymore. It used to in 2008, but now it's being compiled. So ESLint, what does it do? Because there's steps. The tooling has to do a few things. So first, it parses. So every time you want to change code into an abstract syntax tree, you need to parse it, analyze the text, build the object model. So it first parses it, then it traverses the thing, so it looks through the tree, analyzes it, and then it complains, right? When it finds something wrong with your syntax, but it's not searching, like it's not using regular expressions to find it in text, it's using the model. Okay, this is a horrible simplification, but for the sake of theory, Prettier, Uglify, these things are built on a basic idea that if you parse the code, get the abstract syntax tree, you can then render it back into code with some assumptions. So some old versions of tools that would do these things would just take the abstract syntax tree and try to render it to a specific kind of code. So prettification or beautifiers or whatever you used to call them would just render your code again. That's why you lost your cursor position in some older editors when you beautified the code. Uglify or minification of any sort is trying to render it into as small as possible, obviously, while maintaining the right variables and stuff. This is where you also need the abstract syntax tree, so that you don't accidentally replace some variables with something that no longer makes sense as a reference. And in fact, they transform the code a lot, but that's a secret. Okay, Babel. It parses, then it does a lot of transformation from new syntax to old syntax, and then it generates the code again. This is probably how abstract syntax trees and all the tooling around them got that good for JavaScript, because before Babel, barely anyone used abstract syntax trees for practical reasons. Okay, and now code modes. So code modes, the thing I want to teach you to write, what they do, they parse. You get the abstract syntax tree, then you can traverse, which is you can walk around the tree and find the nodes in the tree that you're interested in. Then you can transform, which means take what you found and replace it with something else. and then you regenerate the code. And that's the idea. So we ran out of theory, and we're good on time. So now I can slow down. So what are code modes? When you want to build a code mode, you need the thing that does the parsing and generating. One of those things is recast, fairly popular. I think I have it somewhere. Okay, that's not recast. That's recast. Okay. So it's a tool, you can install it and you can use it, and it looks fairly complicated until you look at this, and now it really looks complicated. So yeah, that's not what I'm going to show you how to do. Recast has a function called visit, which goes through the tree, iterates over nodes, and you need to write your own code to identify what you're interested in and what you're not interested in. So you're actually exploring the whole tree, and the control flow is really weird. So instead, we can use JS CodeShift. JS CodeShift is the tool I'm going to focus on now. JS CodeShift is the jQuery of AST traversal, and I mean it as a good thing. So it makes it makes going through the abstract syntax tree easier and more convenient, just like jQuery was helpful in the old days when you needed to find nodes in your document object model. It's been built at Facebook. It's less complicated, so how do we use it? Okay, I'm gonna show you the repository because it would be unfair if I didn't. So here it is. JS CodeShift, it has a CLI, you write the transform. It says here that it's a wrapper around recast, also useful information. You install it, you have a lot of options to choose from, and you write a transform module, which is a little simpler, just a little. And there's some fun API in it. So let's go through what we're going to try to do here. Let's learn how to do the magic. So there is some resources. By the way, this is going to be available. It's already linked on my website. Nauktur, you can Google it. Everything you find is going to be related to myself. No one else uses this bit of text for anything. So there's a weird thing about documentation. So documentation is written as a GitHub page, but Facebook organization is pretty big, and they took over the domain, and the GitHub page is not accessible. So someone forked it and hosted it for you to use, and it's here. This is what the documentation should look like. It's fairly useful, but it's not necessary. I'm going to tell you why in a second. But the biggest resource that I want to recommend is AST Explorer. And this is great. Like you need to learn anything about AST by practicing it, use this. So here, top left, we have a bit of code. As you've seen on the right side of it, we have the abstract syntax tree, and you can highlight bits, and there's layers here. So this part is tokens. We're generally not interested in tokens. Let's ignore this. We want the program. So we go into program, there's body. Body is the whole program. When you touch anything in this right side area, it gets highlighted. So it's easier to find. We have a declaration. And inside this variable declaration, we have an identifier and a literal. And if I open the identifier, it says that the name is demo, and this is rather simple code, right? Then bottom left is the transformation. So this page is also going to run the transformation for you. You can experiment with it live. This is the example transformation where it takes every identifier you have in your code and reverses it. So it finds, like, okay, let's look at the jQuery stuff. So conveniently called JS code shift is the thing where you grab the source and you call find to grab an identifier. It finds all identifiers, so all variable names or all function names, everything it would find, and then you can take, you can make a for each on that and replace each of them with something you build up. It can be a string, but it can also be a bit of an abstract syntax tree, which we're hopefully going to get to. And this funny bit here, split reverse join, is how this gets reversed. Okay, not very useful, but shows you how to use the tool. And don't hesitate, it gets a lot of getting used to before you start really understanding how to explore the tree and how to do something more than just finding an identifier. But it's definitely a lot of fun when you do. Okay, so some other resources. Traversing methods are documented, but you can also look at them in the code to understand what they do better. And I really recommend that. Read them, they're fairly simple. You can guess what they're doing and then have some ideas what to add and then discover someone else did it. Then building the AST part you want to replace into your code. You need some types for that, and those types are defined in a separate repository, AST types, but you don't really need to go there. Because if you do all the right importing in your editor, it's going to suggest the right things to you, so that should work. So use autocomplete instead. And now a recipe. So what do we want to do to build a transformation? First, you need a good example snippet. So take a bigger chunk of your code for experimenting with, because if it's too small, it's going to be easy to introduce side effects that you didn't expect. So, you know, if you're changing how your promise logic works, take a longer chain with a lot of thens, so that you notice if you start replacing all of them instead of just one. Then you need to work on traversing your tree and finding the right nodes. When you do that, you probably need to go up to find the right scope to replace it. And then you construct the replacement from some constructors and run the replace done. Let's see it in action. Here is an example of the first two steps. So you're building your transformation, and if you want to make sure that you reached the right node, this part is like is your copy-paste solution. So you want to do the finding and any filtering that you might want to do. So it says find everything that's an identifier that has a name of foo. And then in the for each, you replace it with something easy to notice. And that means your code is going to get transformed and you see what you found. You don't need to build the whole replacement logic yet. But this lets you prove to yourself that you found the right thing you wanted to replace with something else. Demo time. Okay, that's the hard part. For you, not for me. It's going to be hard to look as I scramble. Okay, let's go in. So there's this code shift demo I have here. I'm going to figure out how to publish this later. So this is an example of a bit of code that's also under NDA, which uses an SDK that's luckily open source. So I built an SDK for a JavaScript SDK for the APIs of the company I work for. And then 5 years later, we decided we want to change the API a bit. So the API used to be chained. You would say file ID, this thing, .get, and it would get the information about the file from the storage. Ignite is doing storage unrelated. And then you could do some other things like customize the request, add some interesting stuff like lock tokens, and then find the file by path and move it somewhere. So there's a lot of chaining here. And the new syntax was supposed to be just call the function, give it one object with all the parameters it needs. So imagine refactoring that in the 30-something applications we have built on top of this SDK. Sounds like a lot of fun, right? Okay, demo. So first, this is what a transform looks like. You've already seen this on the slide. Your code goes here, boring stuff. If you run this, nothing happens to the code. Okay. Now let's skip ahead to this. So this is almost the example from the slide. It says find an identifier that's called then, and replace it with the capital this. Okay, let's pin this one and open this for reference. Okay, and I'm gonna run the transformation. While looking at the codes. Okay. Did I run the right one? Nope, I didn't. Okay. Okay. So what happened? This showed up. So now I know that my transformation that I put in here is finding the then identifier correctly and replacing it with whatever I give it to replace it. And I don't see any other occurrences of this, which means my traversal was correct. Now, what if I want to just replace one of those? That's going to be a bit harder. So this is where it gets a little tricky. Not much, but it took like 2 hours of figuring out how to find the particular one element that I want to replace when a similar thing occurs multiple times in the file. So the find thing accepts more information in here. I'm gonna wrap it into view, and here I'm looking for a call expression, which is a function with the parentheses and everything, and I want it to have arguments where there's an object that has parameters, and the name of the parameter is file metadata. That sounds complicated until you look at the code where there's a function with this argument, and this is what I'm finding first. And then when I find the call expression, I'm going deeper because the call expression is the whole row actually. So the call expression is the whole thing here, where the argument is a function. I'm gonna have to revert the file, by the way. And I'm then going into that call expression and looking for an identifier. That's the specific then. So let's run it. Oopsie. Okay. Okay, did it work? let's see. So it put this in here, but it didn't replace the second then. That's what I wanted to achieve. And like, if you only remember one thing from the whole presentation, this is it. How to do the traversal, a more complicated one. You need to put a lot of structure here, and you need to debug it with a this. That's generally how it works. This is what took me the most time out of the few hours I spent experimenting with this initially on one evening, till I got the gist of how it works and was able to do anything meaningful with this technology. So now that we already know how to find things, we can start replacing things. So here is the same example, but now we're building stuff. So we can replace with things. And here, okay, you know what? Before I run it, I'm going to tell you one more thing. So here we're going into building the target AST you want to put in place of your previous code. And the important part is you probably have no idea how to build an AST. Like I had no idea. And I looked for documentation. It was hard to find. I found the documentation on this forked repository and stuff. But then I accidentally discovered I didn't need it. And that's probably why no one noticed they don't publish the documentation. Because if you import JS code shift and not use this reference, or if your transformer is a part of a bigger thing and the editor can figure it out, your IDE is going to suggest stuff. So I can remove this and show you that if I put a dot here, it suggests things, and the capital letter ones are the types you can put in the find. So these are the types themselves. And if you want the constructor, you need to look for the lowercase one, in this case, identifier, for example. So I choose the identifier and I get all the suggestions I need, so I don't need to read any documentation, right? Yeah, this is good. This is good. I can write code without reading documentation. Back to my daily work. Okay. So now we have a transform that replaces then with a catch, and it replaces a particular one. So looking back at the code, there's stuff, and then there's this then with a file metadata here. I'm gonna replace it. Okay. Okay, it worked. Yay, I didn't humiliate myself yet. Okay, so it finds the particular place, it replaces the thing with a new thing. You can build a bigger structure here, and that's what I'm going to show in a moment. So this was hopefully easy to follow. Now let's switch to something that's not. And I'm going to spend the remaining time trying not to overwhelm you with this. So this is the actual transform that I'm writing for my job, which is going to, okay, let's give ourselves a bit more room. Which is going to be replacing, okay, replacing the old usage of the SDK with new usage of the SDK. I'm not going to force you to go through the whole thing, but bear with me for a moment. So first, looking at the code, I want to get all the cases where we're using ignite.api, which is conveniently a weird enough name that no one else uses it. So I can just match it by text. I don't have to make sure it's been required from the right package. And with this transform, I'm finding the identifier ignite. And then I'm going up. So this is the fun part. So find is going down, like in jQuery, right? Dot find would go down from a node that you've already found. And then closest is like jQuery's parent it goes up the tree and finds the closest member expression in this case, which is name dot something else. And here I'm looking for a member expression that has the property of API. So now I've found each time where ignite.api shows up in the code. And I have the reference to the whole member expression, which also contains the whole chain below. So now I can go through the reference I've got, and this is going through the chain. I'm not going to go into details, but this is going through the chain of calls until it finds the first then, because none of our own methods are called then. So the chain finishes with a function that returns a promise. So I'm finding the replacement target. This is the thing I'm going to replace. And now I need to create the replacement. And this might be interesting to you, because create replacement is extracting some information from the code that already exists. So I'm getting the function names and the attributes of those functions, merging it all together into a reference object, and then I'm using it to build this. And this is the interesting part. It says, build me a call expression, which contains a member expression. Yeah, it sounds horrible, but what it's actually building is it's building ignite.api.function_name, which is the name of the last function in the chain, and then everything else is rebuilt into an object passed as an argument. That was way too complicated. But the key takeaway here is that you can build any sort of code as an AST with these constructors by putting them all together. You can use the bits of existing code to build totally new code. And if you're if you're really ambitious, you can make HTTP requests somewhere, get some data, and put that in your code, because why not? So this is just code, and it writes your code. So why not? Okay, and then when we have the replacement, it's just, again, replace with replacement, done. So let's see what it does. Okay. So reminder, the code looks like this. There's a storage API that has a get method and some stuff on the way. And then there's storage API, which has a move method with some stuff on the way. And when I run the transform, I get this. Storage.get has a file ID param inside of the object that is given as options, and then inside here there is the move command, which has a path and the whole modify request with a function and a lot of stuff inside of it. So now imagine trying to do that with find and replace. You would definitely mess up the whole function that's been given as an argument before. There's no other way than to parse the code, transform it, and then write it back again. So that's what I did. One long evening. I'm hoping this was helpful. Let's switch back to the presentation. Yep, that's the whole thing I wanted to show you. So I'm hoping this was helpful to get you started. I'm hoping this wasn't too scary that you would. So please try it out. Whenever you see that you have a lot of refactoring to do, this is cool. Or whenever you have an evening and you don't know what to do other than Netflix, you can do this instead, which is what I did and I recommend. Thank you.
Questions? Okay.
Hi, thanks for presentation. Two questions. One, out of curiosity, how long it took you to get to the last code mode?
So the last code mode is 90% the result of the initial research. So when I saw this, I thought, hey, this could be useful for this particular thing. And I already started with this. So I started learning as I went. And it took from finding astexplorer.net to getting to 90% of this. It took me like 4 hours. And then I spent another hour fixing it after I understood traversal better. So the traversal had a few unnecessary steps in the original version. Yeah, that's it. So if you already know what you're doing, this thing should take about an hour to write.
Okay, great. And the second question, have you tried like manual refactor of a code and then writing a code mode that will replicate this manual refactor? Because my case is like I've got 12 applications to refactor and they are all pretty much the same, using the same shared libraries, but I have to apply more or less the same changes to all of them.
Okay, it's going to be a long response. My team is building integrations. So each month or month or two, we're shipping a new app to production. We have 30 Node.js apps in production. And they have to be very similar because we're very likely to drop the code base for like a year or so and then have to go back to it because someone wants a new feature. And we're doing that all the time. So we need to keep them updated. So there was a time when sed was my editor of choice. If anyone knows what sed is, it's applying regular expressions to files in batch. But that wasn't enough. And there's no ready-made solution where you write the refactoring once, you get the diff and you extrapolate to other projects. But refactoring once could be useful to learn what you really want to do. And then you write this. So but it's a good idea to generate a code mode from an actual refactoring. It takes you one level up, right? Yeah, we have to go deeper.
Yeah, because the biggest problem I saw so far was to generate the code that generates the came up with the code that generates the abstract tree, especially that I'm not familiar with the abstract tree of JavaScript. So that was my idea. Okay.
Yeah. When we automate everything, some work is going to be left to humans to continue building the automation.
Have you tried using the Babel template set of tools for building the AST, the replacement AST from what looks effectively much like a string of JavaScript source? Do you know what I'm talking about?
Nope, I didn't look into the Babel tools much. I went straight for CodeShift because this was the thing I could understand in an evening. So yeah.
I would recommend looking at Babel /template.
Okay.
Effectively, JS CodeShift is using Babel inside it. So it's the same AST there. And that lets you not have to manually build the whole AST with those operators that you were using.
Oh, okay. So you mean instead of this mess, I could have something that looks more like code, right?
Yes.
Okay. Yeah, appreciate it.
Okay.
Hi, thanks for the presentation. So navigating through the AST is something very complicated, especially with very large code base. Have you ever considered to plug it with some TensorFlow or something else to automating it with artificial intelligence powered to bring some models to detect some flaws in your code and optimize the way you navigate through the AST?
Well, the problem with using artificial intelligence in general is that you have to have a well-defined outcome to be able to judge the results, because the whole process of training it is based on recognizing if it's doing its job or not. So making a very clear definition of what the output should be, in most cases is going to be more expensive than sitting down and writing the code yourself. That's my assumption. But in cases where you can simply say that you want the code to still pass tests and not match a certain regular expression that's, I don't know, let's assume you're changing var to const. You want to get rid of all of vars. So you have a regular expression that says there's no var anywhere. That's a good fitness function for a genetic algorithm. So if you wanted to go with something that makes the code modes for you, I would suggest going towards an evolutionary algorithm instead of machine learning, because it's less buzzwordy maybe, but it's way easier to grasp.
Anybody else? Last chance.
Okay.
Okay, thank you.
Yeah.